Hello friends, welcome to Susan and John MathTube. This is lesson number 3 in the examination preparation series for the first year engineering students. In this lesson, we are going to learn about differential equations, and we'll be learning the second order differential equation in your syllabus. As always, the most important question: how to use these video lessons efficiently and effectively. And I'm sure you know point number 1, that is, you should be ready with a pen and a paper. And point number 2, the most important thing, make sure you work out all the problems along with us. And there is point number 3, and point number 4 is very important. Once you complete watching this video, make sure you work out a lot of questions. Keep in mind, you will never get marks unless and until you work out a lot of questions by yourself. These video lessons will give you the concept, and once you watch the video lessons, you'll be able to understand the books by yourself. And that's the advantage of the lesson. But if you want to master on a subject, you have to work out a lot of problems. And as always, the last point, try to work out from past year's question papers. And now let's start with the video, that is differential equation. So we're going to learn about second order differential equations. But for the first few minutes, let's discuss about the basics. So look at this. Suppose I write x minus 1 equal to 0. You'll understand that this is an algebraic equation. And by the word solution or solving an equation, what we do is we try to find the unknown. That is, we don't know the value of x. So we try to find the value of unknown which will balance this system. Anyway, you know how to solve this equation, and you'll tell me the answer is 1. And the reason is 1 minus 1 equal to 0, because if I plug in 1 instead of x, then that equation will be balanced. Now look at this. Suppose you have something like sin x is equal to 1 by 2. This is called a trigonometric equation. And when I say solve this equation, it means you have to find the value or values of x which will balance this differential equation. And there are many values here. 30 degree, you can use a calculator and check it, 150 degree, 390 degree, and it goes on like this. So solution means the value or values which will balance a system. Now look at this. A differential equation means an equation which will contain dy by dx. For example, I have a differential equation dy by dx equal to y, or maybe let's write equal to 0. So dy by dx minus y equal to 0. Now solving a differential equation means finding the value of y. Of course, it will be in terms of x. That is, we want a function in x, or we want the value of y which will be in terms of x, which can balance this equation. And by experience, I know that the solution is e to the power x. Look at this. If I plug in that y value, what is the derivative of e power x? Yeah, e power x. Minus what is y is equal to e power x. See, that is a solution. And one more interesting aspect is, if you get any particular solution, this is called a particular solution, then all the multiples of this particular solution will also become solution. For example, if I take 2 into e power x, then tell me what will be dy by dx. Yeah, 2 into e power x. So when you plug in this value instead of y, then you get 2 into e power x minus 2 into e power x equal to 0. So this is another particular solution. So remember, the general solution is y is equal to some arbitrary constant into e power x. Whenever we find the general solution of a first order differential equation, this is called a first order differential equation because we have only dy by dx. Okay, there will be an arbitrary constant. Okay, now suppose you have another equation d square y by dx square plus y is equal to 0. This is a second order differential equation. Now look at this. A second order differential equation will always have two arbitrary constants in its solution. Anyway, I'm going to guess a solution. I'm going to write sin x because I'm 100% confident this function will satisfy this equation. The reason is the derivative of sin x is cos x and the second order derivative of sin x is minus sin x. So if I plug in this instead of y, then I get minus sin x because the second derivative is minus sin x plus the y value sin x is equal to 0. So according to our previous logic, 2 sin x, 3 sin x, 3 by 2 sin x, every quantity will balance this equation. All these functions. So look at this. C sin x, let's say C1 sin x will be a solution. But this is a second order differential equation. That means I can find a linearly independent, look at this, these are connected actually. Y is equal to sin x and y is equal to 2 sin x. They are linearly connected. They are, what do you call, this is, if you multiply this by 2, you'll get this. So there is a linear relation between them. But the theory tells you there will be a linearly independent solution, and that of course is cos x, because I know the second derivative of cos x is minus cos x. See, this will be minus cos x, and if I plug in cos x here, I'm going to get minus cos x plus cos x, which is equal to 0. Now look at this. The most general solution of this equation is y is equal to c1 sin x plus c2 cos x. So what I'm trying to convince here is, given a second order differential equation, expect two arbitrary constants in the general solution. Okay, with that, let's start with the method. Okay, now look at this. You have to understand dy by dx can be written as capital dy, and d square y by dx square can be written as capital d2y or d square y. You can read in both ways. And if there is the third derivative, you can write d3y or d cube y. Okay, so given a second order differential equation, what you do first is you convert everything into capital D format. You will get a quadratic or a cubic or a fourth degree equation depending on the order. Okay, I'll tell you the best method is, let's start with one example so that you understand the procedure. And one more thing, we are learning a technique. We are learning a technique to solve differential equation. So don't expect any logic when you learn techniques. Technique means it's kind of like a shortcut. So we are trying to learn a method so that you'll end up with the solution very fast. We are not going through the theory or the logic in solving these differential equations. We are just learning the techniques so that in your other engineering subjects, whenever you get stuck with a differential equation, you'll be able to solve them. I'll repeat once more. In engineering, your aim is to learn applied subjects. And when you learn applied subjects, you will definitely get locked up with differential equations. And when you get locked up with differential equation, unless and until you learn in math, you'll never be able to solve them. So Our aim is very simple in engineering course. I have to teach you a few techniques so that you're able to get the solution really fast. Okay, let's start with the differential equation. D square y by dx square, let's say minus 3 dy by dx plus 2y equal to 0. Okay, we are going to start with type 0. And type 0 means the right side of our second order differential equation will be 0. So the first thing to do is you convert this into capital D. You can write this as d2y minus 3 capital dy plus 2y equal to 0. Now you can take common, but remember this is an operator. So you cannot write y times, so it will always keep the function on the right side. Okay, now the next thing to do is you'll write something called auxiliary equation. So what are you going to do next? You're going to write something called the auxiliary equation. And auxiliary equation means you replace each and every d with some other letter. I'm going to use m. In many books they follow the same notation. So the auxiliary equation is m square minus 3m plus 2 is equal to 0. Now use a calculator and solve this equation. So we will get 1, 2. Okay. Now I have to give you the formulae. Look at this. You can use a calculator or you can use any other method to solve this quadratic equation. So the roots are 1, 2. Now something very, very important. Look at this. This auxiliary equation can be quadratic or cubic or fourth degree or any sort of equation. And when you solve, you'll get values for m. Now suppose number 1, the roots are real numbers but different. Let's say alpha and beta. In this case, you have to by heart, you have to memorize the solution is y equal to c1 e to the power alpha x plus c2 e to the power beta x. Now suppose the roots are real but equal roots. And in this case, you must remember the solution will be c1 plus c2 times x into e to the power alpha x. Now the third possibility, the roots are imaginary, the roots are complex numbers. Let's say the roots are alpha plus or minus I beta. And in this case, you must remember the solution is e to the power alpha x times cos beta x plus sin beta x. So there is no other option. You have to remember these things. So when you solve the auxiliary equation, the roots can be real and different, real and equal, or maybe imaginary roots. And depending on the situation, you write the following. Now look at this. Suppose we get alpha, beta, gamma, 3 different roots. Just keep on extending. The solution will be c1 e power alpha x plus c2 e power beta x plus c3 e power gamma x and so on. Okay, now let's go back to the question. So look at this. They gave you a differential equation and you change the differential equation into capital D, and then you constructed the auxiliary equation, and when you solve the auxiliary equation, you got real and different numbers. So the solution is y is equal to c1 e to the power 1x plus c2 e to the power 2x. That's it. As easy as that, provided you know 2, 3 formulae. Okay, now let's do the next problem. So we are discussing type 0, and type 0 means the right side of the equation will be equal to 0. So let's solve one question. So the question is like solve the differential equation, the second order derivative, 7 plus 10y equal to 0. So what's the first thing to do? Yeah, so you write d2y minus 7 dy plus 10y equal to 0. That is equal to 0. Now the next thing to do is write the auxiliary equation. So you have to consider only this part. That is m square minus 7m plus 10 equal to 0. Now use a calculator and solve this equation so that you get the values of m, and m is equal to 2 comma 5. So the solution is, now look at this, the roots are real and different. So you have the list. So if the roots are real and different, then the solution is y is equal to c1 e to the power 2x plus c2 e to the power 5x. Now let's move on to the next question, type 0. So the next question is solve d square plus 6d plus 9 of y is equal to 0. So clearly this is type 0 because the right side is 0 and this is a second order differential equation. So the first thing to do is you write the auxiliary equation, and that is m square plus 6m plus 9 is equal to 0. So m is equal to, use a calculator, minus 3 comma minus 3. Now look at this, the roots are repeated. So the solution is, or the most general solution is, y is equal to, take a look at the formula, this formula, c1 plus c2x times e to the power minus 3x. Now let's try one more question. So they're asking solve. Okay, so the first thing to do is you write the auxiliary equation. So how do you write the auxiliary equation if it is in the standard form? Yeah, m square plus m plus 1 equal to 0. Now use a calculator, you'll get the values minus 1 by 2 plus or minus I root 3 by 2. So this is the last possibility, that is the roots are in the form alpha plus or minus I beta. And if the roots are alpha plus or minus I beta, then the solution is y is equal to e to the power alpha x, and then in brackets c1 cos beta x plus c2 sine the same thing into x. It's not visible, but it's the same thing into x. So that's it. That's all we have to do in type 0. Now let's do one more problem, because I have seen many students getting confused with this particular question. So please write, solve the differential equation d square y by dx square minus 2 dy by dx minus y is equal to 0. So what's the first thing to do? Yeah, change this into capital D. So this is d2y minus 2 dy minus y is equal to 0. That will be d2 minus 2d minus 1 of y is equal to 0. And the next step is, yeah, you know very well, auxiliary equation. M square minus 2m minus 1 equal to 0. Now use the calculator and solve. M is equal to 1 plus or minus root 2. That is m equal to 1 plus root 2 comma 1 minus root 2. Now look at this. There is no fourth case. I told you there are only three possibilities. The roots can be real but different. The roots can become equal or complex numbers. So what we do here is, these are real numbers but different. So the solution is y is equal to c1 e to the power 1 plus root 2 times x plus c2 e to the power 1 minus root 2 times x. So that's it. So let's move on to type 1. So look at this. In type 0, the right side was equal to 0. Now we are going to learn the technique for type 1. So the question is, solve the differential equation d square minus 3d plus 2 of y is equal to e to the power 5x. So look at this. In type 1, the right hand side will be an exponential function, or it will be connected to an exponential function. That is how you remember. In type 1, the right side will be connected with an exponential function. So generally we can write e to the power ax and let's say some constant. Okay, anyway, the technique goes like this. First you start with the auxiliary equation. You can ignore the right side. You have to focus only on this part and write the auxiliary equation as always. That is m square minus 3m plus 2 is equal to 0. Now use a calculator and find the values of m, that is 1 and 2. Now look at this. The roots are real but different. So the auxiliary equation gives us the solution, and that solution has a name. It's called complementary function. That is y equal to c1 e to the power 1x plus c2 e to the power 2x. Okay, so that part is done. Now look at this for the right side. And now what we do is we'll find something called particular integral or particular solution. So I'm going to write particular solution, and that is actually given by, it's kind of like, this is an operator. So I'm using the inverse operator on both sides. So this part will become the identity operator. So I get 1 by d square minus 3d plus 2 of e to the power 5x. Remember, this is not a product, it's kind of like operation. And I'll tell you one more fact. Capital D stands for differentiation, the first derivative, and d square stands for differentiating 2 times. So naturally 1 by d stands for integration. So if you ever see 1 by d, remember you have to integrate. And if you see 1 by d2 or 1 by d square, you are supposed to integrate 2 times. Anyway, this is not 1 by d square but a combination of d's and d square, but 1 by, and hence the name particular integral. So there is a technique to find this value, and that's very easy. All you have to do is you have to substitute, or you have to replace d with this 5. So you're going to get 1 by 25 minus 15 plus 2. Now it's just simple multiplication, 5x, and that is e to the power 5x, the whole divided by 10 plus 2, 12. Okay, and then the general solution. Now we are going to write the general solution of this given equation, and that is nothing but y equal to complementary function plus particular integral, and that is equal to c1 e power x plus c2 e to the power 2x plus e to the power 5x the whole divided by 12. Okay, let's do one more question and make it more clear. So we are in type 1, and type 1 means the right side of the differential equation will be an exponential function. So look at this. Solve the differential equation. D square minus 2d plus 5 of y is equal to e to the power minus x. So now tell me, what are we supposed to do? What is the technique behind this? Okay, first we write auxiliary equation. We just ignore everything and we consider only this part. So the auxiliary equation is m square minus 2m plus 5 equal to 0. Use a calculator and solve. Anyway, I got m equal to 1 plus or minus 2i. So this is the third possibility, imaginary numbers, complex numbers. So the solution, which is called complementary function, is y is equal to e to the power 1x times cos 2x plus sin 2x, and we are supposed to multiply here by c1 and this by c2. Okay, now the thing which we learned earlier, now we will consider the whole equation, and we are going to get a particular solution for the whole equation, and that is very simple. We do 1 by the operator which you see here on both sides, and that will give us the identity operator on the left side, and we'll be able to find y. So, and that is called particular integral, and the particular integral is y is equal to 1 by, you can read that given operator, of e to the power minus x. And I told you the method is very simple. Just replace d with whoever is along with x, that is minus 1. So 1 by minus 1 the whole square, and then 2 into minus 1, and then we have plus 5 of e power minus x, and that will be e to the power minus x by 8. Now that's it. Now we write the general solution of the given equation is, how do you write the general solution? CF plus PI, that is e power x into c1 cos 2x plus c2 sin 2x plus e to the power minus x by 8. Okay, now number 3. Okay, and this slightly different than the previous problems. So the question goes like d square plus d plus 1 of y is equal to 7. But I told you we are learning type 1, and type 1 means the right side will be an exponential function. Now look at this. In such cases, what we do is we use a trick. E to the power 0 is 1. So e to the power 0x is equal to 1. So I'm going to write 7 into e to the power 0x. Now let's start. So what's the first thing to do? Auxiliary equation. M square plus m plus 1 equal to 0. Use a calculator, we get m equal to minus 1 by 2 plus or minus I root 3 by 2. So the third possibility, and that means the complementary function is y is equal to e to the power minus 1 by 2x c1 cos root 3 by 2x plus c2 sin root 3 by 2x. Now the second part, pi. What is pi? Particular integral. 1 by the operator of 7 e to the power 0x. I told you this is something like integration. In integration, when you get a constant into function, what will you do? Yeah, you're going to throw this 7 outside the integral. So that is exactly what I'm going to do. I'm going to keep this outside the operator. So I'm going to write 7 times 1 by d square plus d plus 1 of e to the power 0x. And what is the technique? Yeah, we have to replace d with 0. So 7 times 1 by 0 plus 1 and e power 0x. So you end up with 7. And finally, the general solution is, you know what to do, add them up. That's it. Okay. Now I'll repeat once more. We are in type 1. Type 1 means the right side will be an exponential function, and type 0 means the right side will be 0. And now this question is very important, because we are going to learn the next technique. So the question is, solve d square minus 3d plus 2 of y is equal to e to the power 2x. Okay, so what will we do first? Auxillary equation, that is m square minus 3m plus 2 equal to 0. If you solve, we'll get m equal to 1 comma 2, and which implies the complementary function is y equal to c1 e power 1x plus c2 e to the power 2x. And one more important thing, the order in which you write the roots are not important, because as students you might be confused whether it's okay to write 2 comma 1 or 1 comma 2. So the order is not important. We'll just get it like c1 e power 2x plus c2 e power x. That's it. And these are arbitrary constants, so that doesn't make any difference. Okay, but here you have to notice one thing. Our root and this power, they are both same, and that is how you represent, and that is how you recognize this type. Okay, now the particular integral. Now you'll understand what I meant. 1 by the operator of e to the power 2x. Now do you know what will happen if I substitute this 2? Think about it. That's why I told you the root and this power are the same. Let's try. So 1 by 4 minus 6 plus 2. The denominator is going to vanish. You're going to get 1 by 0. That is why I told you these two things are same. Okay, anyway, whenever you get this, the method is different. What you do is you put 1x, and then you differentiate this as if this is an algebraic function. You know the derivative of x square is 2x. So kind of like that, and you know that the derivative of x is 1. You know the derivative of x cube is 3x square. And you know the derivative of a constant is 0. So now what you do is you differentiate this with respect to d. So I get 2d minus 3 into 1 plus 0. Okay, now the same process, you replace d with Mr. 2. So we get 1 by 2 into 2, 4, 4 minus 3 e power 2x, and that will be x e power 2x. And then what to do? General solution is y equal to cf plus pi. Substitute and write. If you don't write, they won't give marks for the exam. Okay, let's move on to one more question before we wind this video. Okay, and that is d square minus 6d plus 9 of y is equal to e to the power 3x. Now tell me what to do first. Auxillary equation. That is m square minus 6m plus 9 equal to 0. Use a calculator and solve. We will get 3, 3. And that implies the complementary function is y equal to c1 plus c2x times e to the power 3x. Wait a minute, I already noticed something. The root and the power, they're same numbers, so we are going to end up with 1 by 0 for sure. Anyway, let's give it a try. So the particular integral is 1 by the operator of e power 3x. So if you substitute d is equal to 3, you're going to get 9 minus 18 plus 9. So 9 plus 9 is 18 minus 8, 0 as expected. So what is the method? You put x and then you differentiate the denominator with respect to d. So we get 2d minus 6 into 1 plus 0 of e power 3x. And then you put, now we're going to get 0 again. You put 3 over here. Yeah, no need to worry. You just put one more x and then write the remaining part, that x, and 1 by, you differentiate this again. So you get 2 into 1 minus 0 into e power 3x, and that is x square by 2 e power 3x. Now the general solution as always is CF plus PI, that is C1 plus C2x into e to the power 3x plus, where is our PI? Yeah, x square by 2 e power 3x. So that's it. We covered type 0 and then type 1, and type 0 means the right side of the equation will be 0, and type 1 means the right side of the equation will be an exponential function. So I'll be back soon with lesson number 4, and in lesson number 4 we will learn type 2 and type 3. So till then, bye.